So let us discuss about the effects of different alloying elements on high-speed steels. Before discussing about it, let us discuss about high-speed steels. The steels which maintain high hardness at temperatures up to 5500 degrees Celsius are called high-speed steels. These can be used as cutting tools at high speeds due to which high temperatures are developed in the tools. They are also known as high-speed tool steels. They are commonly used as cutting tools in tool bits, taps, drills, and all due to its high hardness and high abrasion resistance. Abrasion resistance. Cutting through materials at high speed is one of the most important advantages of high-speed steel. This is due to the properties such as hardness, wear resistance, and high temperature capabilities. Another advantage of the high-speed steel is that it can offer speeds up to 7 times that of traditional alloys. The disadvantage of high-speed steel is that higher acceleration and deceleration rates and spindle start and stop results in faster wear of guideways and all, leading to higher maintenance costs. Now let us discuss the different effects of alloying metals on high-speed steels. Alloying metals are added to the high-speed steels in order to improve specific properties such as strength, wear, and corrosion resistance. Effect of cobalt on high-speed steels. Cobalt increases the bonding strength in the steel and changes the microstructure of the finer secondary carbides. Also, the growth rate and the coalescence rate of the carbide decreases. This causes the red hardness and tampering resistance to increase. Effect of vanadium on high-speed steels. Vanadium is added to high-speed steels as a scavenger to remove slag impurities and to reduce nitrogen levels in the melting operation. It also decreases the cutting efficiency. It also increases the cutting efficiency of the tools. The addition of vanadium promotes the formation of very hard carbides, which increase the wear resistance of the.
To explain the changes in properties when alloys are added to high-speed steel. My friend Hari has said two effects, and the rest will be explained by me. And the third one is effect of chromium on HSSs. Chromium is included mainly to enhance hardenability and reduce oxidation during heat treatment. The inclusion of cobalt improves hot hardness in high-speed steels, though brittleness increases as well. The fourth one is effects of tungsten on HSSs. Tungsten adds hardness and wear resistance to HSS alloys. In particular, it adds to hot hardness, causes secondary hardening, and enhances resistance to the tampering. Many of the first types of high-speed steel incorporated high tungsten content. The fifth one is effect of molybdenum on HSSs. Mold in tool steels increases their hardness and wear resistance. The sixth one is effect of manganese on HSS. The effects of manganese in improving the mechanical properties of steel depends on its carbon content. Manganese also reduces the critical cooling rate during hardening, meaning it increases the hardenability of steel. Its effects on hardenability is higher than other alloying elements. The seventh one is the effects of silicon on HSS. Silicon helps increase the steel strength and hardness, but it less effective than manganese in these functions. So I am stopping my.
I am Gautam. Today the topic that I am going to take is about alloy steels that have specific applications, mainly about rail steel. First of all, I would like to speak about free cutting steel or free machining steel. So what is free machining steel? Free machining steel is steel that forms small chips when machined. This increases the machinability of the material by breaking the chips into small pieces, and thus this avoid entanglement in the machinery. This enables automatic equipments to run without human interaction, and free machining steel with lead also allows for higher machining rates. And then free machining steel's cost. Its cost is about 50 to 20 percentage more than the normal standard steels, but this higher cost can be offset by increasing the machining speed, large cutting, and long tool life. There are two types of free cutting steels: high sulfur steels and leaded steels. High sulfur steel contains 0.33 sulfur percentage of sulfur and 0.12 percentage of phosphorus to improve machinability. The lead steel contains lead up to 0.35 percentage, which improves machinability. These steels are used for manufacturing axles, bolts, screws, nut, special duty shafts, connecting rods, small and medium forgings, cold upset wires and rods, solid turbine rotors and gear shafts, armature, keystrokes, forks and hanger ball screw stocks, spring clips, turbine, pipe, lightweight rails, concrete reinforcement, etc. Now about rail steel. The steel used for railway track should possess a good combination of strength and ductility along with high impact and fatigue resistance. So, in addition to, we can add manganese and chromium up to 1% to improve these properties, or a medium carbon steel up to suitable heat treatment can also be used for the purpose. The combination of alloying and heat treatment are possible in railway steels, and hence a range of graded can be produced in the case of rail steels. Tensile strength and toughness can be increased by heat treatment, and this heat treatment can be applied either on the whole cross section or only on the railhead, providing a very large wear resistance. Head hardening rails are normally used in heavy loaded tracks, sharp curves, and in turnout elements.
So, as a continuation of what my friend has discussed in the previous slide, now let us discuss about the spring steels. A spring steel is a name given to a wide range of steels used in the manufacture of different products, including swords, saw blades, springs, and many more. These steels are generally low alloy manganese, medium carbon steel, or high carbon steel with a very high yield strength. This allows objects made of spring steel to return to their original shape despite significant deflection or twisting. The various applications of the spring steels are: they can be used in piano wires, spring clamps, antennas, vehicle coil springs, and leaf springs. Spring steel is commonly used in the manufacture of swords with rounded edges for training or stage combat, as well as sharpened swords for collectors and light combat. Now let us discuss about the tool steels. The group of alloy steels which are used for machining and shaping metals is called tool steels. These are used to make different types of tools like chisels, hammers, punches, cutting tools, dies, shears, etc. The tool steels must have high hardness and wear resistance along with high toughness and resistance to shock. Also, they should possess these properties at elevated temperatures. These requirements are attained by addition of chromium, tungsten, molybdenum, vanadium, manganese, silicon, and cobalt to high carbon steel. They are commonly used for making cutters, reamers, bits, etc. used for machining metals, plastics, and woods.
So high strength low alloy steels, HSTA, is a type of steel like carbon steel, but the difference between carbon steel and this steel is that this type of steel has higher resistance to corrosion and has better mechanical properties. And the thing is that the composition of chemical composition of this steel will not be specific. Won't be having specific chemical composition, but rather will have specific mechanical properties. This type of steel has very low carbon content from 0.05 percentage to 0.25 percentage. The purpose of this carbon content is to retain the formability and weldability of this metal, and many other small metals are also included in this alloy to make its properties, mechanical properties, and to achieve the desired mechanical properties. The other copper, titanium, vanadium, niobium are added for strengthening purposes. And this HSTA steel is used in cars, cranes, bridges, etc. because of their lightness when compared to carbon steel, and also they can handle large amount of stresses, and their strength to weight ratio is really high. The next type of steel is thermomechanically treated steel, TMT steel. We all have heard about the steel bars. This type of steel is having superior properties such as weldability, strength and toughness and ductility. And this type of steel is having slightly more carbon in them, about 0.17 percentage to 0.24 percentage, along with sulfur up to 0.05 percentage, and phosphorus. In TMT steel bars, a process is carried out called a thermomechanical treatment is carried out by simultaneous application of heat and deformation process. In this process, the steel is heated simultaneously and quenched to metastable state. After heating to a certain temperature, the steel can be deformed into many shapes as required. It can be rolled, it can be beaten into swords and everything. And after attaining the desired shape, this steel is quenched to normal room temperature by dipping into some oil, or by suddenly reducing its temperature, which will temper the steel. Like in the sword forging process, this process is also used to increase the strength of the steel. These steels are also used to manufacture a wide variety of products like axles, bolts, screws, nuts, special duty shaft, connecting rods in the engines and all, and many other things, mainly for forging and all. These are used, and for making many products, TMT steel bars are used.